This is the ROS Developers Podcast, episode 85.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that give you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all those people out there that they are trying to control the joints of their robots, but using ROS. Okay, so that's the ROS Developers Podcast. Then we control things with ROS. So for those of you there, you know that there is a package which is called ROS Control, which is the one that provides us the ROS access to the joints and to manage all that. And then we can use those controllers with Move It and something else afterwards, and then make our armed robots to do nice trajectories over there. So if you are one of those there, then this episode is dedicated to you. Now, why I'm dedicating this episode to these kind of people? Because today we are going to talk about one of the main developers of the ROS Control packages here today. But before going into that, let me share with you our, our ROS Ignite. I would like to talk about the Robot Ignite Academy. That is the academy that we have built at The Construct in order to teach you about how to learn everything about ROS and also about robotics, because as you can see, we have some other courses like common filters, kinematics, robot dynamics, and so on. So I think that you can have a look at all the list of courses that we provide because it's quite complete, including Linux for robotics, for example, or Python 3 for robotics, in case that you don't know how to program still in Python. Okay, so have a look. We have a complete and comprehensive material there that you can use to master your ROS skills and become a ROS developer, of course. Okay, so after having said that, then I think that it is time that we go with our guest speaker here today. And I'm very glad to introduce you with Bence Magyar. And Bence and I, we worked together some years ago at Pal Robotics. Actually, we were developing some stuff for the RoboCup competition at that time. It was quite fun. It's when we met the first time there. But now Bence, so he has evolved, and now he works as the lead software engineer for a company called FiveAI. That's okay, but the main reason that Bence is here is because also on top of that curriculum, he is the main maintainer of the ROS Control packages. And he is here today to talk with us about what are those ROS Control packages, what are their current situation, what about ROS2 with ROS Control, and so on. So let's welcome Bence to the podcast. Welcome to the podcast, Bence.
Thanks so much for having me.
My pleasure to see you again. So long time that we didn't see each other.
Yeah, this episode is long due.
It's not what?
It's long due. I think the first time we were discussing this was in 2017.
Yes. Yes. But that's cool because at that time, I think that we were not thinking about ROS2 Control. We were more thinking about yes in general. Yes?
Yeah.
Okay, great. Then, so this time has been useful in order to mature the subject that we are going to discuss here today.
Absolutely.
Great, great. And then let me start with the first question. So what can you explain to the audience what is ROS Control?
Yeah, very good question. So it is, the definition is something along the lines of ROS Control is a C++ framework for implementing and managing robot controllers with focus on real-time performance and sharing of controllers in a robot-agnostic way.
What does it mean?
so I know this is quite a mouthful. So there's a lot to it.
Okay.
If we're going to go through a couple of key components, then it can be broken down into C++ interfaces within the ROS control framework. There are some standardized ROS interfaces that ROS control provides. And there is a hardware abstraction layer that it uses to basically provide the robot agnostic features for anyone implementing ROS control for their own robots. And then, of course, probably the most important part actually is the library of controllers.
Yes.
So we maintain a good standard set of controllers that I believe by now they've done a lot of work in warehouses and care homes and similar facilities around the world.
Yeah, and that means that the people that uses ROS control, they don't have to implement those controllers already because they can use the ones that are already there. For most of the cases, they are going to work, right?
Yeah, and most importantly, I think what makes it really appealing for most people is that these are controllers that are tried and tested really, really well. Yeah. So, if you take the deep drive controller, for instance, that's a piece of software that is very simple at its core, but it's actually operating in many warehouses as far as I learned over the years. So there are many startups using this specific controller on their robots.
Great. Then this is what is ROS control right now, but and then we can say that ROS control. So we need ROS control for having those. What would be the reason of why we need ROS control in our ROS robot? So what would be?
Yeah. So the origins of ROS control actually they go back to the PR2 controller manager framework. Yes. So it's an very old piece of software, and it's a very clean idea of wanting to manage the life cycle of controllers and provide basically interfaces to the hardware in a way that you can incorporate any kind of let's say real-time control frameworks as well, or any communication channels that you may have to your hardware that may not go through ROS directly. So ROS control is essentially a generalization of the PR2 controller manager framework from the good old days.
Exactly. Because at the beginning there was only when ROS started. So the guys from Wheel Garage, then they implemented this interface, but only it was kind of very, very specific for the PR2 robot, right? And then so people tried to use it in other robots because they saw, wow, that software is cool, but they couldn't because it was too difficult to detach from the PR2, right? Yeah,
they ended up. There were a couple of robots that were essentially running the PR2 control manager framework just by copying the entire controller stack and renaming things where it was necessary and reworking that parts of the software that had to be changed to make it work on their robots. So in a way, people basically did kind of pave the way for the more general approach.
Okay. And then ROS control then is a generalization of this mechanism for any robot.
Yes.
Right. Okay. And then on top of that, on top of that is not only this generalization mechanism, but also it provides this list of already existing controllers. So that's like another added value, right?
Yes, exactly. Yeah. Okay. Yeah. Over the years, like what I learned, or the main takeaway for me was that the framework can actually, the framework doesn't really matter that much. If you get it, there are many ways to get a framework. There are many ways to get a framework right. The main value is in the controllers.
Okay. Okay, and then imagine that I have a robot that I have built for my company, and then I want to put ROS Control on it. So what would I have to do? So do I have to download the packages of ROS Control and then do some configs on the configuration files for the controllers, and that's all?
Unfortunately, it's a little bit more involved.
Okay.
So for the controllers, for setting up controllers, yes, that's basically that's pretty much what you would need to do. You would need to have a URDF available for your robot, and you would need to, well, you would need to read the description of the controllers and understand which kind of which kind of typical configuration your robot matches.
Okay.
But the key thing to make it actually work on your robot would be to implement your own hardware abstraction layer. Okay. Which, like in the C++, the C++ name of this is robot hardware. So people may, if you Google for robot hardware implementation, you will find a lot of people asking questions about this. It's not a trivial task. Yeah. Fortunately, there are a lot of good examples out there that could be used. There's also ROS Control, the ROS Control boilerplate package created by Dave Coleman.
Yeah, from Moobit guys, right?
Yeah, quite a few years ago. And the ROS Control boilerplate it's basically a generalized robot hardware implementation where it captures all the basics that you would do. Or if you want to go one step beyond that, it's also very easy to copy paste that piece of code, do the changes that you have to do to it. Let's say to support some custom communication, whether perhaps your robot is using the CAN bus, perhaps it's using EtherCAT, perhaps it's using both to communicate to different components. And this is something that you as a robot developer, or actually a hardware developer in a way, would need to accommodate for.
Great. Then let me summarize. So what I have understood then, I have my new robot, which has some articulated joints that I want to control. And then for that, I'm going to use the ROS Control. So I download it, and then I have to build my robot hardware interface, which is a small part which has to be written in C++, and is the one that basically follows the instructions of the ROS Control. ROS Control specifies how you have to build this in order to follow a format, a specific format. And basically it contains the read and write functions for reading the status and writing the status. Okay, so I have to implement only that. And then if I'm lucky, but it's very likely, I can use the controllers already there. And then I will be able to control my joint with those controllers by using ROS.
Yes. Yeah.
So you don't have to be thinking about the signals that you have to send to your joint in order to follow a given trajectory, because you have Moobit that generates those for you and then sends through ROS to the controller, ROS controller, and then it goes there.
Yeah, and then you get the Moovit is actually one of the, so our two main clients are Moovit and the navigation stack.
Exactly.
So and the two main controllers that are serving these two main clients are the joint trajectory controller, which is responsible for moving a robot arm from a given joint state to another joint state in the smoothest fashion, or let's say in a smooth fashion. It also supports preemptive behaviors where, let's say that the arm is halfway there, but then you send it already a new goal. It is going to merge those two trajectories so that it will not generate jerky movements, which may be dangerous for both for people standing around robots and also for the hardware. You don't want the hardware to do crazy things, because that may also pose some danger to people standing around those robots.
Okay, that's amazing. I didn't know.
And you also want to have these movements of the robots smooth, because that's how they're easier to. It is easier to get the intentions of robots if they are moving smoothly.
Yeah. Okay. Yeah. Exactly. It's like you can predict that it's not going to do something sudden that is going to. Okay. And it's providing security, and also is one step towards collaborative robots. Then.
Yeah.
Okay. Great. And one question: how did you get involved into the ROS Control development?
Yeah, this was it was very easy. All you had to do is sit right next to the previous main maintainer of ROS Control. That's how tribal this worked out. Yeah.
Who was?
So I was working at Pal Robotics
at that time,
from 2012 to 2015.
Okay.
And during this time I got involved with ROS Control. We were the first ones to have a robot that basically used all the controllers available in ROS Control, and having backed up with a real-time system that was communicating with hardware.
The course, right?
Yeah.
We had Luca on the podcast 2 weeks ago, two podcasts ago, and he was explaining about using real time and some things that. Okay.
Yeah, I think that ROS has been very influential to not only to ROS Control, but also to in a way to ROS2 and the life cycles, and it is a very, very well done system.
Yes, actually that's what Luca was mentioning, that then now ROS2 allows you to have real-time control inside the ROS node, and it's implementing the same mechanism as a ROS is doing now for ROS1.
Yeah.
Okay. And then what happened? Yeah. But you were there, and then
so like my first contribution was my first bigger contribution was the diff drive controller. That was the last missing piece for us to fully migrate one of the RIM robots to ROS Control. Because before that we had the arms, we had the head, we had other things, but there was no mobile-based controller in ROS Control at that time. So we put together the diff drive controller in a week or two, and then we were really amazed by how easy that was. Also, so it was a good test of the framework at that time.
Okay. And the person that you were seated next, it was Adolfo.
That was right next to Adolfo. Yeah.
Okay, Adolfo Rodriguez, who was one of the early maintainers of ROS Control packages and developers. Okay. I knew only just some bits of that story, because I was still there at Pal Robotics working with you when you were developing that, but not the whole development there. And then it's nice.
Yeah, so Adolfo was working a lot with Dave Coleman, in collaboration with Dave Coleman and his team. And I think, I took over maintaining ROS Control with ROS Indigo, starting with ROS Indigo. So actually, it was quite a while ago. That's many T-shirts ago.
Yes, that's a good measure. The T-shirt, also we can measure in ROSCONs, right?
Yes.
There's many ROSCONs. No, but T-shirt is better, because there is one T-shirt per each distribution.
Yeah,
that's better. Okay, very cool idea, that one. Okay, then, so you have explained what is ROS Control, and then at present, ROS Control is widely used in the ROS world, right? There are many robots that are using it.
Yeah, I think we never really did studies on this. It would be pretty hard to do studies on this, but I would say it's probably half of the robots out there, half of the ROS using robots out there are using ROS Control. And probably I would say probably like the main, like one of the strong reasons is that we have Gazebo support for ROS Control. So if you have a robot that you set up with ROS Control, then with minor or no tweaks to your controller configurations, you can run the exact same setup in Gazebo, which makes testing in simulation extremely streamlined.
Yeah, because it's like if you had the real robot, so you don't have to change anything.
Yeah.
Well, you have to change a small part, which is on the. So okay, so you explain what is the difference then when you are using the ROS control in the Gazebo simulation rather than using it on the real robot?
So the main difference there is that you would not be using your hardware abstraction layer or your robot hardware implementation, but you would be using the Gazebo plugin, which implements the robot hardware implementation, so the robot hardware for Gazebo.
Exactly.
And then this plugin knows from the URDF how to recreate your robot in simulation and have all the same interfaces.
Exactly. Then all the rest is the same. The controller manager, the controllers, they are the same. So they really don't care. Actually, the controller manager doesn't know who he's talking to. He doesn't know if he's talking to the real robot or he's talking to the simulation. And then when you plug into the simulation, then you are instantiating just the hardware interface instead of the plugin of Gazebo. That's all.
Yeah.
Okay.
Yeah, exactly.
Okay. Yeah, and that's amazing. That's very cool. Simplified.
I think that's one of the key selling points.
Okay.
I think. Yeah. Because otherwise, there are other plugins for Gazebo. But they either implement interfaces for, like ROS interfaces for specific robots, or they implement a controller as a Gazebo component. So it's kind of simulating as if you had your controller on an integrated board that speaks ROS.
Yes. Yeah, but then that cannot be used then later on the real robot.
Yeah,
that's a problem.
Yeah, but that's
because
it's
a plugin for Gazebo. In this case, let me clarify that because I think it's a very important point to see the importance of ROS control is that the plugin inside Gazebo is just as the hardware interface for the simulation. So, but all the rest is the same. So
so maybe. Well, one of the examples could be like the setup of one of the REAM robots where there's a controller for the head, there's a couple of 2 degrees of freedom, then there are 2 joint trajectory controllers for the 2 arms, there's a div drive controller, there's one more controller for controlling the joints of the torso. And all these, if you were to start them up node by node, or load individual plugins for every single one of these controllers into Gazebo, that would be very hard to maintain. Also, we had a very good experience. Like straight after getting this to work on the REAM robot, we were on the REAM H robot, so the wheel-based ones. We were also using it while developing the REAM C, which is a biped, and of course, provided that all the dynamic attributes of your robot is set up accurately in the URDF, Gazebo can reproduce a full dynamic simulation, which means that you can even run very complex controllers in Gazebo without a problem. And like one of these very complex controllers was the whole body controller for the REAM C robot that is responsible for keeping the biped upright and walking, and also doing other things
at the same time.
Yeah.
And that would be very, very complex to be done. To maintain, basically first to do it and then to maintain. And now it's just a set of ROS controllers, right? And their configuration files. So yes, okay. So I hope that the people out there that they are listening to this, so they are with the money ready to buy the ROS control, so they are expecting somebody to sell to them somebody. So please, somebody create a business based on ROS Control. Okay, so now, so we know that importance. So now what is the status of ROS Control in ROS2? So what can we do?
So you can do what we have already been discussing.
Okay.
One of the Actually, do you mind if I flip this question around and talk about limitations instead?
Okay, great. Yes, excellent. Let's go.
So there are the general use cases that I described can be done, but there are a couple of caveats.
Okay.
So one that was extremely bothering me, and I spent a lot of time trying to refactor ROS Control to get out of this kind of locked in situation, that currently a joint interface needs to support, or can only support, position, velocity, and effort. And this is extremely limiting when you're trying to do more advanced things. Of course, this will cover kind of, let's say, 95% of the use cases. But we were trying to accommodate everyone and also keep the framework extendable, so that we don't need to work, but people can define their things more freely. But the code base of ROS Control is pretty complex. So it makes maintaining it quite a challenge. Also, documentation-wise, like that's been an eternal struggle for us.
I know.
Yeah.
Because
we're always trying.
Okay, so, sorry, but we were trying to create a course for that to teach ROS Control, and then we only managed to do a ROS Control 101. So with the basic things, controller manager, the different controllers, the plugins, and so on. But about, for example, for the hardware interface, the robot hardware interface creation and all that. Wow. That is...
You should have called me earlier.
Yeah, okay. That's right. That's my mistake. That's right. But now we are in the correct path.
Yeah, exactly.
Yes.
So, but actually, you touched base on the next limitation I wanted to mention, which is that you need to implement the hardware abstraction layer.
Okay.
So ROS Control in ROS 1 it's halfway there, where I would like it to be in terms of the hardware abstraction layer support. We have. I'm not sure if you do product placements, but I'm going to say
sure, you can.
The Shadow Robot guys have been amazing throughout the years. They helped us improve the joint trajectory controller multiple times with very, very good insight. They also contributed the combined robot hardware package, which allows you to create a robot hardware from multiple robot hardwares. The cool thing with this is that it allows robot manufacturers, such as Shadow Robot, who make amazing dexterous hands,
super cool,
to implement the robot hardware. To implement their hardware abstraction layer, put it in a plugin, and ship it off. The only thing that the end user needs to do is to add a configuration file to their setup.
Wow!
And then that hardware abstraction layer is going to be loaded. Unfortunately, this is kind of a layer on top of ROS Control, but we are making this a first-class citizen in ROS 2.
Okay.
One of the other limitations is, it kind of ties into this, which is that ROS Control is C++ only. We received a lot of feedback that people wanted to implement their own controllers in Python. It was just so ROS Control being based around plugin lib and mechanisms of plugin lib, it makes it extremely hard to work with Python, because plugin lib is basically C++, shared object loading at runtime. Unfortunately, there's no room for Python there. But we've been thinking about how to make this happen for ROS 2. We don't really have a good idea yet, though.
Okay, yeah.
And then a couple of minor things that comes to mind is the update loop in ROS control is there's one and only update loop with a fixed rate. So if you want to run a certain controller at 20 hertz and another controller at 100 hertz, that's not going to happen. So both of them are going to run at whatever update loop whatever update rate your main loop has.
Okay.
And also this means it's a single threaded operation, which kind of still works well if you're working with, let's say, serious controllers. So you're in a real-time system. You don't want multi-threading necessarily there. And
would you consider then also a limitation the case that you cannot have a real-time controller inside the node of ROS? Would you consider that a limitation or not? Because you can do the trick like
so
Luca explained, to use a ROS outside and
even for ROS2 real-time safety or soft real-time you will only have if you're running with a certain kernel patch.
But
so it's not something that you can just include as a C++ library, unfortunately.
But assuming that you have that patch on your kernel, even having that patch in ROS control for ROS1, you cannot have real time, because just because the kernel has been patched doesn't ensure that your node is going to run on real time.
So with ROS control, if you have your real-time patch, then you will have real-time.
With ROS control, ROS2 control, you mean? Or
no, ROS1 as well.
Okay.
So that's one of the other selling points.
Okay. So
of the framework is that it is real-time safe, and which means that if it is in a real-time safe environment, if it is executed in a real-time safe environment, then the execution of controllers is going to be deterministic, and you will have all that nice stuff.
And then, for what are the guys from Pal Robotics using Orocos? Why do they need to go into Orocos?
They use Orocos to implement this kind of real-time safety environment. So they are using Orocos as part of their. They have an additional layer under the hardware abstraction layer.
Yes.
Of ROS control, which they use Orocos for to implement.
Okay. Are you okay?
Yeah.
Okay, great. It's just it's not coronavirus, right? It's just.
I have actually tested positive for coronavirus a week ago.
Oh, where are you? Oh, okay. And how do you feel?
Oh, absolutely fine. The only strange experience I had was the complete lack of taste and smell.
That happened to you? Oh, okay.
Yeah.
Do you know? Oh no, you don't know this guy. Is Alberto? He's one of the teachers here.
Him.
Okay, you know him. And then Alberto from here, he got also the coronavirus, and then we had to be tested, all of us, and so on. So fortunately, in my case, I'm not, because we are very separated, because we see each other from time to time only.
Yeah.
So, okay.
Yeah, it was really strange, because like I've been working from home since March. And haven't really been going out. So the only like the two main places we were going out to was the playground,
okay,
and the closest supermarket.
Okay, so it's
one of those.
One of those.
I suspect those kids.
Okay, great. Then having said to everybody out there about our coronavirus status, then let's continue with the ROS control thing. And you were mentioning about the drawbacks or the things to be improving ROS control, and anything that we are still missing on that list?
No.
Okay.
Well, actually, there's one thing that some people try to implement a couple of times, and it's possible to implement it, but it's tricky, which is chaining controllers.
Okay.
So let's say that you want to set up, for instance, a simple chaining of controllers would be that if you have a separate proportional a separate derivative and a separate integral controller, then you could set up a PID controller by chaining these three. But then, of course, you could have much more complex things as well, where you would have you could have a controller determining. You could have a joint trajectory controller, let's say, which uses some virtual joints and sends those goals off to a whole body controller on a humanoid robot. So but then the joint trajectory controller could try to nudge this controller, the whole body controller, into doing something. But if that's unable to do so, for instance, because the robot is walking or slightly out of balance, it would take care of these things.
Okay, so it's like implementing the whole body control inside the ROS control.
Basically.
Okay, a basic.
That would be another implementation.
Okay, and then having found all those limitations of ROS control, then now it comes the superstar ROS2 Control.
Yeah.
And why do we need ROS2 Control apart from migrating ROS Control into ROS2?
So ROS2 Control started, I think, in 2017. Started with a proof of concept implementation, very rudimentary, but it basically had a joint trajectory controller and a deep dive controller, outward facing interface, so that it could be used, but the code was very far from the actual code of those controllers. The implementation of the framework was fairly similar to what we have in ROS1. But again, it was only a proof of concept that lasted a little bit longer than originally intended. We didn't really have, it took 2 more years after that for us to get together and finally start working on ROS2 Control for real now, and trying to improve all those limitations that I just mentioned.
Okay.
So one of the things there is that we wanted to make the combined robot hardware basically a first-class citizen. So we are still in the process of reworking the framework into a component-based system, which means that every single hardware component that you have on your robot it does not come from a robot hardware class, a single robot hardware class, but they are loaded from the URDF of the robot. So
you mean including sensors, for example?
Including sensors, yeah. So basically, in a way, the way to think about it is that you would list your drivers and the configuration of these drivers for your robot in your robot description, in the appropriate ROS control tag.
Okay.
And
in the URDF.
In the URDF, yeah. And then when the whole system is starting up, basically you create the robot hardware by composition from this from the different drivers. And these different drivers would create the necessary interfaces that the system is then going to serve to the controllers.
Okay, so I'm not sure if I have understood. Okay, let me tell you what I have understood is that at present, if we have a robot with wheels and a laser, then when I switch on the robot, I have to launch my ROS node that connects to the laser and starts publishing the data to a topic, to the scan topic. Yes. And also I have to launch another node that is controlling the wheels. And then that's a ROS control node that is using the diff drive controller inside. And it's publishing the joints in another topic. What you mentioned is that, so instead of launching all that, then I will have inside the URDF, I would include the specification of which laser I do have and which wheels I do have. And then I only have to launch the ROS control node. It's going to read the whole URDF and then he's going to instantiate Is something like that? I'm close to the more or less. Not so far. No, not yet. Okay.
Somewhat.
Okay.
So the sensors configuration comes into play with respect to the ROS control or the ROS2 control framework.
Okay.
So basically, this allows us to define sensor drivers that will be loaded into ROS control, sharing the same update loop, sharing the same node environment. Therefore, in ROS2 terms, that means the possibility to use shared memory to communicate.
Okay.
Which again takes us back to real-time safety, so that you will not have to use a network for communication. Because this is something that this is actually something that was also a limitation I forgot to mention. That for supporting different sensors for ROS control, one would need to extend the framework by implementing a couple of more classes, and this would just basically yet another class in the entire framework. This doesn't even allow you to implement specialized drivers. So you would need to still implement everything in your hardware abstraction layer. One of the, like for instance, just an example, we have the force torque sensors implemented this way in ROS control. And we're really unhappy about this because we want people to be able to, bring an arbitrary sensor that plugs into a robot through a USB. And if they can write a driver for this, then this should be absolutely loadable and usable within the ROS2 control framework.
But what is
so we wanted to make this happen.
Okay. Sorry to interrupt you. And then, I don't see the point of, about having the sensors inside the ROS control. Why is it needed to? Well, you mentioned now about using the shared memory inside ROS2, which is very interesting, but there are other mechanisms to do that already provided by ROS2. Right?
Yeah.
Right. So what is the point of using the sensors inside the ROS control? I don't see.
Well, it is. So one of the key things that controllers that is important for controllers is that there is an update loop that is well understood.
Okay.
So if you have some nodes here, some nodes there, publishing things on different topics, you don't really know what scheduling those nodes are going to get, when those things are going to be published, and when were they produced in the first place. So to tie these in with controllers, to tie these in really well and tightly with controllers, this is why we need to expose sensors inside the framework.
Okay, makes sense. I'm not an expert in control of robotics, but that makes some sense. But I would need to, in order to understand better, I would need an example, a concrete example of seeing that in action. That probably is what we're trying to do with this. With this four sensor, was it right?
Mm-hmm.
Okay.
Yeah. So then let me mention a couple of things that we started doing for ROS2 control.
Yeah.
So we now have a demos repository.
Okay.
The sole purpose of this repo is for us to provide a couple of reference implementations. Actually, to take a couple of steps back, we started the whole process of working on this newer version of ROS2 control by first creating a roadmap, a rough plan. Like, we never had such a thing before.
It's a huge improvement. Right?
It's open source. It's a little bit like the Wild West. People worked on what they pleased. So we're trying to make a plan and stick to it.
Okay, great.
Or at least set a direction. And and so one of these things included so that we have a component-based system. But we also wanted to have wanted to resolve some of these limitations from ROS control. So we started working on making the joint interfaces more flexible. And we spent quite a lot of time debating the naming for this. But the key idea is that the interface type of a joint is now a string. It's not a C++ class.
Okay.
The cool thing about this is that you can define it to whatever you want. You only need to make sure that it actually matches what the controller wants to use.
Okay. Okay.
And this way you can not just use position, velocity, and effort, but you can include maximum torque. You can control in current. You can control in acceleration. Basically, all the things that the effort field was overused for and abused for in the past. So we wanted to make sure that people can explicitly express what they're trying to do, and have like more understandable systems this way.
Okay.
We're also trying to massively reduce the complexity of the code base for ROS2 Control. The ROS Control in ROS1 has a lot of inheritance and code injection this way, which is very hard to follow when one is trying to figure out what's actually happening.
When things go wrong.
Yeah. Not even when things go wrong, even when you just want to understand how to build, when you really want to get to the guts of how to build a robot hardware. And so one of the other things that we wanted to make sure that we do is to make use of the lifecycle nodes in ROS2.
Okay.
We mentioned previously that lifecycle nodes are basically ROS nodes that have a similar lifecycle to what Oroco's components have. We wanted to, and in a way, ROS Control was implementing this already for the controllers, being loaded, configured, started, stopped. We're basically now using the lifecycle node states for this, which is pretty great because there's ROS2 API for querying this from the outside already. So we're using standard API for this, and then of course the whole aim of the component-based system was that we allow robot hardware manufacturers to ship their stuff in an easier way, so that nobody needs to implement their own robot hardware and then load other things. That made things easier, but not easy enough. So we want to make it even easier.
Easier, okay.
We still don't have Python support, but the fact that you don't even have to implement the robot hardware probably helps a little bit for getting this right.
Yeah.
It's
exactly.
it's like you don't have to touch C++.
Exactly.
Only for controllers, but that's a slightly different story. So where we are right now with ROS2 Control is that we've been rushing to get to a stable state where we can make a release to Foxy. Our friends at Picnic Consulting, that basically the main Move It maintainer guys, they've been very, very supportive. They've been building Move It 2 along the way, and we are aiming to. They've been adding some of their own robots into the mix. So we're aiming to have some real robot demos with Move It 2 by the end of the year.
Okay.
Similarly, the Pal Robotics guys have been amazing at supporting all this effort. They've been working on adding ROS2 support to their robots. So we're soon probably going to be seeing a Talos and a Tiago with ROS2 Control.
Wow, amazing.
And we also got a ton of support from Bosch. Mostly contributions to the core framework development. And let's say that the controllers work have been done by all the others I mentioned before. So currently we are still applying some finishing touches to the component framework, which was basically a rework of everything. But provided that one is done, we already have all the main controllers, like the classic controllers available in ROS2. So the joint trajectory controller, the deep drive controller, and all the forward command controllers, so position controller effort and all these guys, both individual implementations and the group versions.
And what about the plugin for Gazebo?
Thanks very much.
Okay.
Excellent question. Yeah, so the Gazebo support has been happening along the way as we were developing the framework. Thanks for the Open Robotics guys for working on this.
Sorry, who?
The Open Robotics.
Open Robotics
supported us on working on the Gazebo plugin. They've been extremely patient with us breaking API all the time. So thank you very much. You only have to bear with us for a little bit more. And yeah, so that's basically what I wanted to say.
Okay, so let me ask you one question about the status of ROS2 Control. So because the listeners, they probably are worried. Okay, so if I put my robot into ROS2, am I going to be able to use that and to use ROS Control as I was using it in ROS1? Then, for example, in simulation, we know that, yes, very likely if you are using the typical controllers, okay, effort controllers, velocity, or position, then it's going to work on simulation with ROS2, right? So far? Okay. Then in case that you have a physical robot, then, and so what to expect? So if it's using one of those effort controllers or velocity controllers or position controllers, then it's going to work also.
Yeah.
Normal. So they can go and use ROS2 because everything they will have. Do they have to implement again the robot hardware interface in that case?
So the robot hardware, this hardware abstraction layer that now only comes into play when it comes to components. So if you are implementing your own robot and there's no standard driver for those components, then you have to implement them.
Okay.
So this is what also the thing I forgot to finish it. A line of thought was regarding the demos repo. So we set up everything to follow a certain roadmap, and then within this roadmap, it's in a repository. So I definitely recommend checking that one out. We have a couple of example URDFs that we want to implement a couple of demos for.
Mm-hmm.
And these, we try to capture all the typical use cases, the typical robot setups that people would have. And these are part of our unit tests as well in the framework itself, so that to make sure that we're covering all these bases. Uh-huh. And as we develop, we don't drop support for certain things.
Okay. So let me tell you
this is not all there yet, though. So
okay,
I would only recommend people to have a look at it once we actually made the release to Foxy, unless they feel extremely adventurous, but then expect things to break from 1 week to the other.
Okay, and that release is planned in your roadmap for when? But you mentioned by the end of this year, right?
So we should have demos by the end of the year. We're actually planning to get a release out in November.
Oh, great.
But that may not have all the documentation, the demos ready yet.
Okay. So please, listeners, take easy on the documentation side. We know that always is the difficult part of because you reach exhausted the publication of the code, and now you have to go again to create the documentation, and that's a pain. So we understand. But let me clarify one thing then. This ROS2 Control roadmap is on your website, and also this ROS Control demo repo, it's already there.
It's all in our GitHub repo.
I will
GitHub
put
organization, sorry.
I will put a link on the show notes so people can go, as well as to all the other companies that you have mentioned and products and so on. So just to clarify, because you asked before, can I mention? Yeah, of course, because I mean, you cannot mention and drink Coca-Cola because it's the one that I drink. Okay, so because it's not related to the podcast, but if you are sharing information which is useful for the listeners, that super happy about other companies, about other software competitors of the construct. That's okay also. No problem. This is for the ROS developers out there. So we want them to learn and to get the best information.
Awesome.
Okay, great. And then, so just wanted to clarify about those links, and I will put them, so especially the ROS2 Control roadmap and the demos. I think that this is very interesting. Let me check if I'm missing any of the questions here. About the movie, you also mentioned movie 2, and also about the Gazebo simulations, and also you answer about the ROS controls in the ROS2 Control in the close future, about the releases and features. So I think that we have covered, right, in almost 1 hour, everything about ROS Control. So people can go and and check the links and start practicing with them.
Yeah.
Okay. So thank you very much. And
thanks very much for having me. No, that's all I had to say. I really need to run now to a ROS2 working group.
Oh
meeting
yes, that's
that
right.
I am late for.
Yeah, me too.
I'm very late for.
Yeah, me too. I'm sorry. I didn't see I'm also in another meeting. Just one final question. How do you manage to get time to develop about that? Because you have so many things, your family, your company that is hiring you.
Yeah, so I wake up at 6 and I work from 6 to 8, have a quick breakfast, and then go to my normal work.
Okay. Then thank you very much, Bence. It's been a pleasure to talk to you again since some years ago. Thank you very much, and see you next time. So just let me tell to the people out there that they are listening to the podcast. So thank you very much. This is all for this week. We had to hurry. We don't have more time for anything else. So see you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.